So what we have is we have three machines: server node, tester 1 and tester 2. For the master node in Kubernetes, we need to have at least two CPUs. Kubernetes will not work if you have one CPU. So in order to increase the number of CPU, we go to system of our server machine, go to processor, 2 is the minimum requirement, and start all the three machines. Right now an environment is local resolver is properly configured, IP addresses are properly configured, networking is properly done, and in fact I have also done key based authentication. So I can work on server machine. To work on all the three machines, I can refer only server machine by opening multiple tabs. In first attempt, I am going to demonstrate setting up repositories, running update command and disabling the swap, because Kubernetes require that you don't use swap, and because Kubernetes has a prerequisite that swap must be disabled. So this is what we are going to do. And also on tester 1 and tester 2, Docker is prerequisites, and since Docker is available under developer EPEL, developer repository of Oracle Linux, so we are going to set up the repository for developer on tester 1 and tester 2, because we need to install Docker on tester 1 and tester 2 as a prerequisite. So tester 1, tester 2, let's disable swap, because these machines I'm sure by now they are ready. Let's disable swap, etc fs tab. This is permanent disabling, etc fs tab. The last line talks about the swap. If you see carefully, this is swap. So simply disable it by putting comment in the last line, vi/etc/fs tab. Last line, swap line, ensure that you put a hash that is commented out. And now I am logging into my server machine. The guidelines of Linux says that if you have a RAM less than 2 GB, 1 GB or 512 MB or whatever, the guideline says that your swap area must be double the RAM. Because if you are opening multiple files, multiple programs and software, then you need to swap the files, swap the data temporarily to the disk in order to accommodate more pages for other programs. Adjusting those programs, we need more area, so we convert a part of the disk space for that purpose called swap area. So we hardly have in production that we have only 2 GB of RAM. First is this: if your RAM is from 2 GB to 4 GB, we say that your swap must be equal to RAM. If you have 4 GB to 8 GB, we say that your swap should be half of the RAM. And if it is more than 8 GB, you don't need it. Interestingly, I am hosting around 350 websites, and I have 7 servers my own self, and I have never used swap in any of the servers. First is we have disabled swap on this also. We have disabled swap on all the three machines. First requirement is that. Now let's set up the repositories. This is a Kubernetes repository we need to set up on all the machines. So that is the advantage of opening 3 tabs. I can start the command on all the 3 systems together. Insert mode on tester 2, insert mode on tester 1, insert mode on the server. So on server pasted, on tester 1 pasted. So at least I can say if there is problem, it will be on all the machines. If there is no problem, it will be all the 3 machines will be perfect. So this is Kubernetes repository to download and install Kubernetes packages. So all the 3 machines have Kubernetes repository. On tester 1 and tester 2, I need a developer repository. So for that, I will open my etc yum.repos.d and Oracle Linux repository. I'll go to the last of this by pressing Shift G and then small o to open a new line, and here I'm going to add my developer and developer EPEL repository for Oracle Linux. So this is my developer EPEL on tester 1. Same way I'm going to do the same on tester 2 as well. Shift G will take me to the bottom of the file, small o will open a new line, and paste will do the paste part of it. This is a convention. It is make you easy. Your life will become easy if you follow the same steps the way I am demonstrating. Tester 1, tester 2, all the machines are open in one terminal. Now on all the 3 machines, what we need to do, all the three machines, we should run yum update command, and I'm going to run this command on all the three machines. Though I have updated this, I run this command yesterday only, I don't expect much of magical things here, but it is good to update before you proceed. So this is running on server, tester 1, tester 2. Next will be bridge net filter. I am going to run on all the three machines. First, we disabled swap on all the three machines. Second, we added repositories. On tester 1, tester 2, we added developer and developer EPEL repositories. And on server, we added Kubernetes because developer and developer EPEL were already there on server machine. I configured that for you already. So this is a bridge net filter, enabling it in the running system. This will make it permanent. Remember, this proc file system is your virtual file system for your processes. This will enable in a current session itself. Though I don't require it, I can simply restart my machine, and which I am going to do anyway, by the way. So power off all the three machines. All the machines are off. Now our focus will be the server machine. Let's set up the server or the master node for Kubernetes. Number of CPUs 2, swap disabled, repository set, host machine configured, IP address is working, internet working. So pre-flight check, all tests done. So we are ready to set up the master server. Open these ports, reload firewall, check all, will display all open ports. These are all ports which we have opened. Packages, IP root TC and kubeadmin. Because all the repositories are properly configured, it will go smoothly. Docker daemon.json file. This is mandatory. This file does not exist by default. We are creating it for the security control group. So execute options, native control group driver. By default it is C group. So Kubernetes will throw a warning about this. It will say that it should be systemd, and that you set here by creating this file, and then you can restart Docker. Your Docker will restart. Check the status. Docker must be running. It is a prerequisite for Kubernetes. Kubelet service. As I said, it will not start right now. If you look at the file, it will complain that this file is missing, the config file, where lib kubelet file is missing. There is no such file or directory. And if you check the status, it will say that is not running. But we have to start it. But don't worry, don't panic, because we are going to create it, configure it. Entire Kubernetes works in the form of Docker containers. So we are pulling all the images first, and then we are going to run it. It is done. Now we are initializing it. Kubernetes initialize. Now what is the purpose of this API advertise address? What happens is, if you have multiple IP addresses configured, if you notice we have two network adapters, NAT based and host only adapter. So by default Kubernetes will use the first available IP address. And in this case, the first available IP address will be the NAT adapter IP address, which is 10.0.2.15. And this IP address is specific only to the virtual machine, is not reachable from outside world, not even from other virtual machines. This is same for all virtual machines. So therefore, the 10.0.2.15 cannot be used as IP address of the cluster for the API to be reachable to connect to the server or to connect to the master from the worker nodes or the minions or the agents. Technically, Kubernetes says that they are agents. They are not agents. We call them as minions or worker nodes. But however, these are just labels. Interestingly, Oracle Cloud Infrastructure does not have any such labels. When you configure cluster in OCI, all have same. Why? Because ultimately these are just images and these are just containers, and they can be distributed. So you can organize which container will go where. So therefore, they are just labels for identification. This is not mandatory that which node or which container will run on which node. That's not mandatory, but for the sake of understanding. However, OpenShift, AWS and other, they differentiate it categorically. And AWS, when you deploy Kubernetes on AWS, there is mandatorily you have to add 2 master nodes and minimum 2 to 3 worker nodes. Hence, the line is not very clear with different service providers. For me, I understand it that way, since ultimately they are containers and we are spreading them across cluster. It is okay to have that without any label. And OCI, container cluster for Kubernetes in OCI, have no such distinguish, no such differentiate. You can label them. Here we are going to label them. We are going to talk about one as master, rest are worker nodes, and we are going to label them. So advertise IP address, the region I explained. Pod network. This also is sometimes the culprit that your node or your pods are not working, they are not in ready state, your deployment is not happening smoothly, because the deployment, the plugin, the CNI, container networking plugin which we are going to use, have a specific pod network, the CIDR block. It is exactly this one. If you use some other, it may not work well. The deployment or the containers which will deploy in Kubernetes, they may not be able to interact, even they may not come up. So that's why I'm specifically using this CIDR block. Where it is mentioned, I'll show you that look, this IP address is referred here. If you start your Kubernetes cluster using this pod network CIDR block right in advance, and that will help you. Now see, only one warning is there, and I'm aware of this warning, and I have already done this. Otherwise, you would have shown 2 warnings, 3 warnings, and this warning is firewall. We have already set up the firewall properly. In our case, firewall is not at an issue because we opened the ports. Look the instructions carefully at the bottom. It says Kubernetes control plane has been initialized successfully. You need to execute these commands. To start using your cluster, you need to run the following as a regular user. Yeah, let's use it. Let's create these commands. That's why I told you that I don't need to copy these commands, because I'm going to run it, and this command will be visible to me in the output only. So I'm just executing them. I'm already logged in as root user, so therefore I'm not using even sudo. I can use it, and this also alternatively. I'm not going to use it, but this is important for me. This is important, and the instruction in my lab says take note of it. So don't do anything else. Take note of it means I'm taking note of it. Look, okay, this is the command. What this command is saying? This command is for other nodes to join this cluster. And now you see IP address 10.10.0.100, which is advertised IP address, and the port number, the token and certification hash. This command can be regenerated, the token can be regenerated, you can fetch the token. There are commands to handle these things, so have patience please, I will explain. Networking, wget, just for reference team, you can directly apply it using the command given. Look at this file carefully team, and you will see the CIDR block here mentioned. This is what I was talking about, network. And this is the CIDR block I specified right in the beginning. Network configuration JSON, network should be this, and it should use VXLAN. That is the reason I use the CIDR block right in advance. Now I can apply. Sometime we commit so silly mistake, kubectl, and this is done. So your network CIDR block is applied. It will take few minutes, if not immediate, not ready, try, will show me the pods being created. Now this is pending, you see that, and this is pending, therefore it will take time. Once this is running, you will see the status also ready. Now it is creating containers. Patience is very important team. You notice that earlier it was pending, it took nearly 1 minute or 2 minutes. After that, now it is running state. Now if I see that nodes, it will be ready state. So my master is ready. All my pods are running. and that is Cubase system namespace, core DNS is running, etcd is running, API server is running, controller manager is running, Flannel is running, that is networking part, Cubase proxy is running, scheduler is running. These are all running, and they are all actually, if I say docker ps-a, you will see them nothing but Docker containers only. They are all running container stream. Graphical interface of your Kubernetes cluster. I am directly applying this time. kubectl apply Kubernetes dashboard, and the dashboard is created. So go to that line. This is the command which is used to edit the deployments. And where is that image? I need to find out where is that image referring to. Yeah, here the image, container, auto generate certificate, namespace, Kubernetes dashboard. Here I have to add one line, and mind it, this is the YML file, so it should match exactly the same syntax, exactly at the same location. So edited the file, and you don't have to apply it again, it will be automatically applied. You don't have to change it. And yes, dashboard is running, dashboard matrix running, dashboard running. So my dashboard is also running. Session 16, Introduction to Kubernetes. What is Kubernetes and why do we need it? Terminology, kickstart, installation, initializing, setup network, and build high availability cluster and validate the cluster. That's the agenda. Kubernetes is a very popular option for managing containers and potentially other things. It's a mature open source project. It's based on learning from internal Google projects, also known as K8s. Was developed by Google and donated to Cloud Native Computing Foundation. Extensible, flexible API architecture, and API is exposed in object types. Not necessarily just about containers, because it can manage other things also. It can group multiple containers into a single logical unit known as pod for management and deployment. Architecture of Kubernetes is on control plane or the master, we have API server running. The state data and configuration data is stored in a distributed database etcd. I use this database in OpenStack also. I'm an OpenStack administrator and I deliver training on OpenStack Cloud. I use the same database there also. It is key value pair database. Then resource management, object management is done by controller manager. Scheduler watch for new ports and schedule pod deployments. Kubelet is two-way proxy interaction between the API server and the worker nodes, and it is an agent to be installed on worker nodes. So Kubelet interact with API server, take instructions and manage containers, create containers, manage the life cycle of containers through Docker. And Docker, as you know, manage the containers by using image from the image store, OCIR or Docker Hub. In OpenShift is same thing. OpenShift is this all of them, including giving you a choice here. You can use Podman or Docker. This is another perspective. Kubernetes cluster allows you to create a service that how you want to expose your worker nodes to the outside world. You can expose them through load balancer, through a service, through a dedicated node IP address, or as a service. Choice is yours. So therefore, broadly if you look at a client application can reach to the load balancer, and then appropriately the traffic will be directed to the right pod. Another way of looking at this from the URL which is given at the bottom is this, the architecture. This is image taken from official documentation. On Kubernetes master, we have Kube API server. This interact with Kubelet and Kube proxy on worker nodes. Kubelet handles the pod management lifecycle of pods. Pods are nothing but group of containers, logical unit of containers like transaction in databases. Kube proxy allows the connectivity to the outside world. If pod have to speak to the outside world, the Kube proxy will help you with that. etcd is the database, Kube scheduler I discussed, controller manager, and we are going to discuss each of these components and their role in detail. So have patience. Installation considerations. Before you actually think of deploying it in your production environment, you have some questions you need to answer. Download Kubernetes from upstream repositories on VM or physical servers, but please consider these criteria to consider while evaluating Kubernetes solution for your production use. Very important, will give you a lot of time to think and will propose to your team that whether we should use it or not, and if use it, are you ready? First thing is high availability. Does your Kubernetes solution install clusters that are highly available with replication of underlying metadata for recovery against failures? In my opinion, if you are deploying it on Oracle Cloud Infrastructure, this answer is yes, we are good. Upgrades. Kubernetes community delivers a major upgrade every 3-4 months. What are your Kubernetes upgrade strategy? What is your strategy for that? What downtime will upgrade require, and is that acceptable for your business? Support for hybrid. The kind of solution you might be looking for, we have on-premises infrastructure also, cloud also, Oracle managed complete OCI infrastructure and cloud at customer. So on private cloud, public cloud. Does your Kubernetes solution equally support the private data center and public cloud endpoints that your business needs to deliver Kubernetes on? Are you ready with this? Federation support. Does your Kubernetes solution support installation of federated clusters that can grow across private and public clouds for robustness of infrastructure and dynamic burst stability? Are you ready with this answer? Enterprise ready features. What additional enterprise readiness features does your ops team need to run Kubernetes at scale and large scale of users? Are they supported for your Kubernetes solution of choice? Some examples include single sign-on. You have to adjust, you have to plan it. Role-based access control, isolated networking, persistent storage. I would like to draw your attention team here because this is important discussion, and I'm sure you will feel that Ram, that was quite interesting. You know what? I'm sorry I'm talking against this solution what we have in OCI, but I must say one thing, that if Kubernetes is engine, OCI is offering it as an engine only, but few additional features like security, that is identity and access management, and high availability, dynamic scaling down, scaling up, because ultimately it is using instance pool. Those who are certified architect, everybody know that in OCI we have a concept of instance pool which can be configured to dynamically scale up or scale down as per our need. So we can scale up, scale down by setting up the criteria based on memory uses or CPU uses. We have various criteria which can be used to scale up, scale down. Everything is good, but problem is the persistent storage, monitoring, and other features. Like if I want single sign-on using GitHub, can I do that? If I want single sign-on to my cluster with the Google OAuth, can I do that? I mean authentication, authorizations, monitoring. If Kubernetes is engine, I must add the point, we need a car. We don't just need engine. And for that reason, I would like to draw your attention towards another solution, similar solution, where you'll compare the features what we actually need in production and what Kubernetes offer. Kubernetes does a lot for you. Orchestration, deployment, discovery, health monitoring, some level of security, storage plugins, networking plugins, scheduling, scaling, service load balancing. Excellent. Kubernetes does all these things for you. But doing Kubernetes right is hard, because we need to install, deploy, harden it and operate it. These are additional things which you need to do: templating, validation, operating system setup, provision, infrastructure, identity and security access, we have it, apps monitoring, alerts, storage persistence, ingress and egress, integration, host container, images, build and deploy methodology, platform monitoring and alerts, metering and chargeback, platform security, hardening, image hardening, security certifications, network policy, disaster recovery, resource segmentation, operating system upgrade and patch management, image upgrade and patching, then application upgrade and patching, security patches, continuous security scanning, multi-environment rollout, enterprise container registry. We have a lot of things in OCI also, but not everything. So Kubernetes does not offer all these things. Multi-tenancy we need, self-service, image registry, routing and load balancing, CI/CD pipeline, role-based authorization, vulnerability scanning, metrics and loggings, application services, team collaboration, quota management. These are the features which we need. That is the reason I said, boss, Kubernetes is engine, good, but you need a car like this. OpenShift gives you this kind of car, that you choose the location where you want to deploy it: laptop, data center, OpenStack, Azure, Amazon, Google Cloud, anywhere. Then container host, then orchestration and management, that is engine. And this is the car, that is features offered by any car, multi-tenancy and all those features which were listed. And that is the container part. Not only Docker, Podman or anything is supported. Any OCI compliant container management system can be used here. If Kubernetes is engine, we need a car. Installing Kubernetes on OL7. In Kubernetes setup, we have one master node and multiple worker nodes. Cluster nodes are known as worker nodes or minions. From master node, we manage the cluster and its node using kubeadmin and kubectl commands. Kubernetes can be installed and deployed using minikube, very simple single node cluster for testing. Good example, good use case. You can use kubeadmin, that is multi-node cluster in our own premises, and that's what we are demonstrating, we are working on right now. On master node, we have API server. It provides Kubernetes API using JSON or YML over HTTP. States of API objects are stored into etcd. Scheduler, it is a program on master node which performs the scheduling tasks like launching containers in worker nodes based on the resource availability. Controller manager, main job of controller manager is to monitor application controllers and create pods to maintain the desired state. etcd is a key value pair database. It stores configuration data of cluster and the cluster state. kubectl utility is a command line utility which connects to API server on port number 6443. It is used by administrator to create pods, services, etc. Worker node components, what we need on worker nodes: kubelet, it is an agent which runs on every worker node. It connects to Docker and takes care of creating, starting and deleting containers. kubeproxy, it routes the traffic to appropriate containers based on IP address and port numbers of the incoming request. In other words, we can say that it is used for port translation. Pod can be defined as multi-tier or group of containers that are deployed on a single worker node or Docker host. The environment, Disable SE Linux for the testing phase. Otherwise you can set up, you can create policies. I know how to create policies, but I don't want to get into operating system security part of it. So simply for the time being, disable it. SE Linux and firewall rules. Log into your server, enforce. I have already done it for you. Set enforce 0. This is disabled in your case. By the way, this is simple Linux command, stream editor. Follow symbolic link, substitute SE Linux is equal to enforcing with this SE Linux is equal to disabled globally into this file. Set the following firewall rules. Now I am giving you multiple lines here just to demonstrate those who are new to them that you can go one by one also, you can go into group also, you can go in groups also. But if you are using one, you don't need curly braces. If you are using multiple, then use curly braces separated by comma. In my case, during the demonstration, I use a single line for all the ports. That's fine. Then we need a module, kernel module, that is a bridge net filter module that needs to be inserted in the kernel. By default, is not available. You have to insert it. Local resolver and swap, we have already verified. In our case, we have been working on it. So our etc host file have all these IP addresses already configured and the host name already configured properly. Disable swap using swap of -a, but this is one time. If you reboot, it will be on again. So better to change it into fstab file. We have done it. Kubernetes repository, that is repository file. Interesting point about this file is single line. As I told you, this line is the most likely the culprit if you get errors of the repository or package not found. So I'm double check please this line, last line. It should be one line because in PDF this line is coming as 2 lines. Install kubeadmin and Docker. We already done this. Install kubeadmin, enable kubectl service, restart Docker, kubelet and enable kubelet, and then initialize it. Kubeadmin initialize API server, advertise IP address, your IP address, IPv4 IP address, which is reachable from other machines. That is why we are giving this IP address. Otherwise, this was not mandatory. Output of the command would be something like this. And these are the 2 warnings generated. You notice that in my case, I took care of this. First is this, is Docker systemd check, detected C group FS. And it should be systemd, and we have done it. Second was this TC is not found, so we installed this also. And the third is the firewall. We have already ensured that all the ports are open, so we have taken care of all the warnings properly. And this was the output, last phase of the output, the 3 commands, and take note of the command which you are going to execute on the worker nodes in order to make them join the cluster. Use cluster as root user, executed these commands. Get nodes, get pods, all namespaces, we got the status and all were running. This networking, until networking is deployed, you will see that this is pending. So we deployed this pending status, not ready status. So we deployed the pod network. Team, there are a lot of CNIs available. There are a lot of CNI means we deployed Flannel using that, and there is another one also available. Here we are going to deploy a Weave. You can use any of them. You can refer to the documentation for any other available. You can try any of the available networking for your Kubernetes solution. In my lab assignment, we are using Flannel. And then verify. After applying it, you will see that now it is ready status. And in my case, I demonstrated up to here that yes, my cluster is ready. And on the worker nodes, we are going to do the same process. These are worker nodes now. Other nodes, setup, security enhanced Linux, firewall ports, and then same filter. We have done that part up to here. Then repositories on the worker nodes, Kubernetes repository. And also, if you notice the developer and developer EPEL repository we need to set up, and I have done that also on my worker nodes. And then restart Docker and enable Docker. Join worker nodes to master. We took note of the command which was required to be executed on worker nodes, therefore we are going to execute the same command here. This was the command we noted, and we are executing the same command. So output of this command will be something like this. This node have joined the cluster. These warnings we are already taken care of using the same configuration, that is installing the required packages and creating C group file, that is docker.json file under systemd, to use systemd as control group. Verify the installation. We have seen that, verified that. More details are available, like Kubernetes describe nodes, get pods -n kubesystem -o wide, describe nodes, cluster dump. These are a lot of commands to give you more comprehensive output about your cluster. More on tokens and nodes. By default, token will expire after 24 hours. Kubeadmin token create. This is how you can create it. If you don't have value of discovery token certificate hash, which was required to join, you can get it by running this command. Controlling your cluster from machine other than control plane, you have to copy the file, that is admin.conf file. Then you are ready to start. That is kubesettle -- configuration file, wherever the file is located, and get nodes. By the way, we are going to use the same technique. This file, take note of this command. We are going to use the same technique to manage our cluster, Kubernetes cluster, on OCI from the same server machine. I repeat, we are going to use the same kubectl utility, same command, same machine to manage our entire cluster on our OCI, and we are going to use we are going to deploy dashboard on our local server, and that dashboard will show our OCI cluster, Kubernetes cluster. Removing the node, you can do it using this command, kubeadmin reset and drain nodes, delete local data, ignore daemon sets. We stopped at this point, if you remember, that yes, our dashboard is running. After that, what we need to do is we need to create a service account for dashboard, and we need to grab the token for that service account, and then we need to start the dashboard and log in into the dashboard. So let's create the new file, Kubernetes dashboard admin user. Give any name to the file, that is not important. Manifest file, we call it as manifest file. The manifest file specify what actually it is. It is a service account I am creating for a Kubernetes dashboard namespace. So this will create kubectl apply -f and the file name. So this will when you apply this admin user will be created. Now we can start. We need to get the token also for login purpose. The namespace, if you see here, these are namespaces. So the namespace is Kubernetes dashboard, describe secret, and I'm executing this command, and this grab admin user and print the first column. This is quite comprehensive command that will give me the token. This is the token which I'm going to use to log into my Kubernetes. So I'm capturing it in a notepad file, token part. Now I can start CTL proxy. No. So the proxy server is started, the Kube dashboard is started. Now I can open browser. I repeat, team, not repeat, let me clarify. The dashboard is available only where you have installed it. It is not available outside that machine. You have to use this URL to open the dashboard. So token, paste it, and you are logged in. Save the token. So team, you are working in the Kubernetes and the dashboard part. Right now there is no jobs, there is no pods, there are no deployments, there are no services, nothing. However, you can see the nodes, only one node is available, that is your server.example.com. This gives you a visual way of managing your Kubernetes. You will see everything here. We will be working on this after we add other nodes and we deploy. We are going to deploy some applications also. Let's work on the tester and worker nodes now. Let's set them. As usual, we are going to start the same process, SSH tester 1, and then another tab, SSH tester 2. So I am doing on both the systems. Firewall port open. Now I need to reload it. for both the machines, tester 1, tester 2. Firewall reload done. Because tester 1, tester 2 need Docker also. IP root TC same, kubeadmin, Docker, everything we need. So let's install these packages on both the machines. Once the packages are installed, almost done. After this, what are the steps left? We'll start the service. We'll modify the Docker JSON file. I edited the file, docker daemon.json. Here also docker daemon.json file. Same what we did on the server. Both the nodes, and restart Docker on tester 2 as well on both the machines. And here also we are going to do the same thing. And now we are going to execute the command to join, which I captured from the output here. Now let's join the nodes, and let's join tester 1 also. So this command will make tester 1 join the cluster. Only one warning came, that was because of this. So this node have joined the cluster, this node have joined the cluster. So we can verify now that same command, the command to get all ports, all namespaces. Where is the command get all nodes? Yeah, and you can use -o wide. So you can use -o wide and try. It will take few minutes. Just wait. It will be ready because pod network is already deployed. You see, and we are ready. Now the labeling part. This is control plane and master, and I want these to be labeled as worker. So kubectl label node tester 1 as worker. Same way tester 2 also as worker. And good. Now you can verify this. They are worker nodes. So this is a 3-node cluster setup team, and now you can see on the dashboard also that you'll see tester 1, tester 2 are up and running. Alright, that's a setup. We have successfully created a 3-node cluster, all nodes ready. That was installation part.